For this video, we're going to look at addition and subtraction, primarily looking at whole numbers and also using some mental strategies. Our learning intentions, we will learn what the cumulative and associative laws are, and I always have trouble saying that, and also to mentally add and subtract whole numbers using partitioning, compensation, and doubling or halving. Success criteria, apart from being able to say them, will be able to describe what the cumulative and associative laws are, and also describe and use partitioning, compensating, and also halving and doubling mental strategies. So what is addition and subtraction? So this hopefully is revision for you, but addition of course is represented by the plus symbol. Now, the cumulative law for addition tells us that it doesn't matter which order we add values together, we'll always get the same answer. So for the example here, we have 4 plus 3 is also the same as 3 plus 4. It doesn't matter which way around we do the addition, we will get the same answer. So of course 4 plus 3 is 7 and 3 plus 4 is also 7. The associative law for addition also tells us that it doesn't matter which pair of numbers is added first. We'll also get the same answer. So here we have 4 plus 11 plus 3. Now it doesn't matter if we add the 11 plus 3 first, for example in brackets, and then add the answer of that to 4, or if we add the 4 and the 11 first and then add the 3 at the end. It doesn't matter which order we do these additions, we will still get the same answer. And we'll see these laws, the cumulative and the associative laws, coming back with some of the other operations that we do. But it is also important to understand that both of these laws cannot be applied to subtraction. So we have subtraction with obviously the subtraction symbol, but both the cumulative and associative laws cannot be applied. So for example, 4 minus 3 is not the same as 3 minus 4. We can't use the cumulative law of this, for subtraction. So 4 minus 3, of course, is 1. But if we have 3 minus 4, we actually get -1. They are not the same. And the same can be said for the associative law. 8 minus, and in brackets 4 minus 2 is not the same as 8 minus 4 in brackets minus 2. So again, if we do the brackets first, 4 minus 2, of course, is 2. Take that away from 8 gives us 6. So 6 on the left-hand side is not the same as 8 minus 4 being 4, and then take away another 2 being 2. So 6 is not equal to 2. So we cannot use the cumulative and the associative laws for subtraction. They only apply for addition. Now we're going to look at some mental strategies to help us with addition and subtraction. Now I put mental strategies in quotes here because it doesn't mean that you have to solve the entire equation in your head using just your brain. It's really about creating ways that you can do these equations more simply, mostly using your brain, not having to necessarily write down and follow a prescriptive formula or process like the ones we will see in the future. So you'll see in these examples, we still write things down, but it helps us to solve the equation more easily without having to use a calculator, certainly, but also without necessarily having to use a full algorithm, which is something that you'll most likely be learning about soon. So the first strategy is partitioning. So in this strategy, we group together the digits of the same place value. So we've talked about place value before, so that the units are ones, the tens are hundreds, thousands, and so forth. So for this example, we have 171 plus 23. So the first thing I've done is broken these out into each of their place values. So we have the 100 being the 1 here from 171 plus a 70 and a 20, which come from the 7 here and the 2 here in the second number, plus the 1 and the 3 being the unit value of each numbers. So we have 100 plus 70 plus 20 plus 1 plus 3. I've included brackets here just to keep together the hundreds, the tens, and the units, just to help show the partitioning that we've done. Now at this point, again, I've written it down. I'm not trying to actually add these in my head necessarily, but these are much easier numbers to deal with. So I can easily add 1 and 3 to get the 4 underneath here. I can easily add 70 and 20 to get 90, and I can easily bring the 100 back down there. And then I can very easily add the 100 plus 90 to get 190, and I've still got a plus 4. And then of course 190 plus 4 is a very easy thing to do in my head. So the mental part of this is not so much about solving the entire equation in one hit in your head. It's about creating something that you can solve using just your mind to do the actual work, but you might still have to write the steps out. And if I was doing this in my class, I would ask my students to write it out very much like I did here, maybe not with all the circling that I've just done now. The next strategy is compensating. Now this strategy, we're going to convert some numbers into easier multiples of 10 usually, so 10, 100, 1000 and so forth. And then we compensate or basically mark down how we made that change, and we use that as either an addition or subtraction. So in this example, we have 46 plus 9. Now, we could change one or both of these numbers, but we'll go with the plus 9. It's the easiest one to convert, if you like. So what we end up with is 46 over here. We change the 9 into a 10, so it's plus 10. And then to get back to a 9, or what we did to compensate is we originally added 1 to the 9 to make 10. So we have to take 1 away again at the end to make sure that we get back to our real answer. So we have a minus 1 here. Now, each of those numbers is a lot easier to work with than 46 plus 9. And it probably becomes more obvious as the numbers get bigger. So what we end up with is 46 plus 10 is a real easy addition to do in our head. So we have the 56, and we still have the minus 1. And of course, taking 1 away from 56 is very easy to get our final answer of 55. So again, the idea is to take one or more of the numbers that you have in your equation, your addition or subtraction, to turn them into a multiple of 10, and of course to compensate, hence the name, what you did into your equation so that you basically undo it again at the end. So if we have to add some value to a number to get it to be a multiple 10, we then take it away from the final. If we actually took away, so let's say this was 11 and we actually took 1 away, then we'd have to add 1 back in on the other side. So it's a very good strategy just to make your numbers easier to work with, but you just always have to remember what the actual compensation was. And the last that we'll look at is doubling or halving. And it's one strategy, but of course you might double or halve something. So the idea here is, again, that we're about making the numbers easy to work with. And we do that by trying to make two numbers either a double or a half of each other. So it might make more sense as we see the example. So here we have 75 plus 78. Now, 75 and 78, they're not half of each other, but if we think about it, if we had 75 and another 75, that's the doubling that's talked about. It's easier for us maybe in our mind to double 75 than it is to add this as it is together here, 75 and 78. So we end up with 75 being doubled, i.e. we've got two of them, right? So we had the 75 and the 75, but the 75 for the second one is actually 75 plus 3 being 78. So we have the 78 coming in here because we add 3. To me, it's a little bit like the compensation from earlier, except for instead of trying to get to a multiple of 10 to make it easy, we're just looking for similar numbers. So 78 is made of 75 plus 3, and that means we've got two 75s to add together, which might be easier. Now, if it doesn't help you, if finding a double or a half number doesn't help you because you can't do that in your head, then that's maybe not a strategy that works for you. But from here, it works the same. So we're saying in our mind, we can easily add 75 and 75 to get 150. And of course, we've got the plus 3. And of course, 150 plus 3 gives 153. So you've got to look for numbers that make sense to you. If it doesn't help you, then the strategy is not useful. So just because you understand the strategy but you can't apply it well to the numbers that you have, doesn't necessarily make it a good strategy for you at that time. Some questions will certainly lend themselves better to some strategies compared to others. Okay, let's now have a look at a few of the sorts of questions that you might see. The first one says evaluate 3,576 plus 322. Now, just remember, evaluate means to find the answer. So here we're not going to write it out into a vertical algorithm and actually add them up, units, tens, hundreds, thousands, etc. We're going to think about what sort of mental strategies we can use that might help us to do this. So in this one, I might use partitioning. So I'm going to partition out the first number. So I'm going to have 3,000, because that's a 3 in the first column, plus 500, being the 5 in the second column, plus 70, plus 6, and then the second number becomes plus 300, plus 20, plus 2. Now, I like to group together, and again, that could be considered a strategy in itself, group together numbers of the same place value. So I have no other thousands, so I'm going to have 3,000. I should put an equals here. I've got a 500 and a 300, so I like to put them near each other. 500 plus 300, and it might help you to cross them out at the top to start with, so you know you don't miss any. And then I've got a tens being the 70 and a tens being the 20, so I'm going to include those. Okay, I'll cross those out for the moment just to know I've done them. Oh, I just realized I made a mistake. I put a 20 on the end here. That shouldn't be there. In fact, let's rub it out properly, because that should have been a plus 2. And then I've got a 6 and a 2 being units. So plus 6 and plus 2. And again, you can see the crossing out helped me to realize that I'd made that mistake earlier, and I was able to fix it up. So now I can add these numbers more easily. And I do encourage you, in fact, for my classes, I ask for one operation to be done at a time. So this will still take a few steps to get through to show that you've done each part of it. And I'm going to use some brackets here to show the different place values. So the 6 and the 2 are my units. I'm going to put brackets around those. The 70 and the 20 are tens, the 500 and 300, and of course the 3,000 by itself. So what I'm going to do is I'm actually going to solve each of the brackets, and then I'll have one number at the end. So I will have 3,000 still, because that doesn't change, plus let's solve the 500 and 300, which of course becomes 800. The 70 and the 20 becomes 90, and the 6 and the 2 becomes 8. So we have something that's a lot easier. We now have a single units, a single tens, a single hundreds, and a single thousand. So we can easily now make that into one number just by taking the first number in each of these place values. So we have 3,000, the 3 from the thousands, the 8 from the hundreds, the 9 from the tens, and the 8 from the units. So we get our final answer there. So that would be the sort of working out I would expect to see my students doing. The next question says, what is 3,884 minus 433? So again, a question like what is asking you to solve this question. So we're going to do this exactly the same thing with partitioning again, this time just with a subtraction. So we will have a 3,000 being the 3 from the first number. We've still got a plus, because this is still the same number, 800. All right, plus an 80 plus a 4. But now we have the minus sign of the subtraction. So we're going to have a minus 400. We still have a minus 30 and a minus 3. Don't forget that each of the place values in the second number are all subtractions. They're all minuses. If you just put a minus in the middle here, you'll have minus 400, but then you'll add 30 and 3 again, and that will cause a big problem with your answer. So here I'm now going to group them again together, grouping the different place values together. So I'm going to say that is equal to 3,000. All right. I'll say plus for the moment. I've got an 800 and I've got a minus 400 being the amounts that I have in the hundreds places. So I'll put those in brackets, 800 minus 400. And I'm going to go plus, I've got an 80 and a minus 30. So 80 and I'll go minus 30. And I've got a plus 4 and a minus 3. So I'll still do plus 4 minus 3. So I've still got all the same symbols, all the same values. I forgot to cross them out as I used them this time. I probably should have, just to make sure I didn't miss any. Now let's work out our bracket. So we're going to have equals, 3,000 hasn't changed, plus the first bracket, 800 minus 400 gives us 400 left, plus 80 minus 30 gives us 50 left, plus 4 minus 3, of course, gives us 1. And now we've got one value for each of the place values locations, so we can find a final answer. So we'll take the 3 from the thousands, we'll take the 4 from the hundreds, we'll take the 5 from the tens, and the 1 from the units. So we have a final answer of 3,451. And of course, you could check that on your calculator if you needed to. Now, this question specifically says to use compensating to solve this question, 88 plus 9. Now remember, compensating is about taking one or both of these numbers, because we've got 2 in this case, and converting them to multiples of 10 to make them easier to work with. I tend to look for the smaller number to use, so out of 88 and 9, I'm going to work with the 9 to make a nice easy 10. So what I'll have is 88 plus 10. I've turned the 9 into a 10. How did I do that? By adding 1. So now I have to compensate by taking 1 away. So 88 plus 10 minus 1 is the same as 88 plus 9 is what I am saying. So I can now easily do this. So 88 plus 10 is very easy. That's 98. That's where the mental strategy comes in, because I can easily do that math in my head. Still minus 1. And of course, 98 minus 1 is also an easy subtraction to do in my head, and it becomes 97. So here, this part here is where I have compensated by turning the 9 into a 10, but I have to show how I've done that. And of course, 10 minus 1 is 9. So we really are saying that that's where the 9 comes from. And it makes the actual rest of the math easier to do in our head. That's what the mental strategy part means. And now we have to use halving or doubling to solve 50 plus 57. So again, with halving or doubling, I'm looking for something that makes my two numbers the same and that hopefully easier to use, but a bit like compensating, I still have to keep track of what's left over. So if I have a look at these two numbers, 50 and 57, they both contain the value 50. So 50 obviously has a 50 in it, and 57 is made up of a 50 and a 7. And if I've got 50 and 50 to add together, that's a very easy thing to do. 50 and 50, of course, being 100. So that's where my halving or doubling will come in. So my first value won't change. It will be 50. But I'm basically going to say, instead of having 57, I'm going to have 50 again, all right, and 7 more to make up that number. So a little bit like before, this part here is what we're saying. My pen stopped working. There we go. This 50 plus 7 is this 57 here. But I'm saying it's easier in my mind to add 50 and 50 than it is to add 50 and 57. So let's do the first step, which will be 50 plus 50, of course, will be equal to 100. I don't know why I started writing 5. All right, but we've still got the plus 7 there that we need to take account of. But of course, 100 plus 7 is much easier to do. So we have 107 as our final answer. And again, in most of these strategies, if the numbers are small or easy for you to do, you might not consciously think about these strategies, but as the numbers get bigger or longer, these strategies can make working them out without the benefit of a calculator, but at least pen and paper, a lot easier for you. Let's have one more question here. This one actually asks us to partition each number into its place value parts to then solve, so solve, of course, find an answer, this equation, which is 20,460 plus 30,640. So we need to partition each of these numbers into its place values and then solve it. So we've done a little bit of this before, but now we've been specifically told to. So let's partition the first number. It's going to be a 20,000, and then we have a 400, so the 4's in the hundreds column, plus a 60, and plus no unit, so we don't have to show it. And then we're going to have plus a 30,000. We don't have any thousands by themselves. We've got a 600 because we've got a 6 in that column, so 600. And we've got a 40 because we've got 4 in the tens, but again, no units. Like before, I encourage you to bring together or group together your different place values. So I'm going to have 20,000 from the first one plus 30,000 from the second number, and I'll put those in brackets. Cross them out to remember I've done them. I've then got a 400 and a 600, so 400 plus 600. So I'll cross them out to know that I've done them. And I've got a 60 and a 40 in tens. I don't have any units because neither one of those numbers have unit values. Let's solve each of the brackets first. So 20,000 and 30,000. Well, again, we could partition this further if we need to, but we're just going to look at the place values. So 3 and 2 in those first place values gives us 5, and we've got the same number of zeros. So we end up with 50,000 there. Plus 400 and 600, 400 plus 600. Of course, that gives us 1,000. And 60 plus 40 gives us 100. So now we can go through, and again, just taking the place values, we'll work out what the final answer is. So our biggest number is 50,000, so we'll take the 5 from 50,000. Do we have anything from the thousands? Yes, we do. We've got 1,000, so we'll take that 1. Do we have any hundreds? Yes, we do. We've got a 1 there, so we'll put another 1 here. Do we have any tens? We don't, but we still need to show a 0. And do we have any units? No, we don't, so we show a 0. We have to still fill up all the place values down to the units. So we end up with a value of 51,100. And of course, you can check that with your calculator if you need to.